Ralph Louis here. Is it convergent or divergent? Let's check it out. In our previous math lessons, we have introduced the concepts of a sequence as a particular list of numbers, and we looked some basic types like arithmetic sequences, geometric sequences, and even some more of the interesting one such as Fibonacci sequence. We saw how this can be expressed in different ways. As beyond simply listing the terms, they can be abbreviated using a particular expression or formula. We also expanded on this to look at series and summation notation. And this topic is what we're gonna focus on because we are going to be building on that knowledge as we delve into this subject, since we are now understanding differential equations or calculus 3. Alright, so let us dive into this topic, and I will switch over into my band papers so I could explain the topic clearly. Good day everyone, so welcome to the introduction to infinite series. So our goals are to define a convergent and divergent infinite series, as well as to determine if a series appears to be convergent or divergent. Alright, so since we're just finished studying infinite sequences, it's important that we are able to distinguish between an infinite sequence and an infinite series. So remember, an infinite sequence is just an infinite list of terms. So if we take an infinite sequence, so for example, we take a sub 1 and a sub 2, and then sum the terms, we have what it's called an infinite series. So as we see here, we took the list of terms here in our infinite sequence and then add it up, then we have what it called infinite series. Alright? This may seem like an insane concept because how can you take the sum of an infinite number of terms and expect it to be anything other than infinite? We don't know, but it can happen, and we have been doing it. Sounds creepy, right? So let's check this situation. If we bring up the integral from 1 to infinity of 1 over the square of x dx, we can find out that it will be equal to 1. So this means with the limit of integration going to infinity but still yielding a finite number for the area under the curve. So here are definitions of what it means an infinite series to be convergent or divergent. So to be convergent is to have a finite answer. And for a series or integral whatever to be divergent means it has an infinite answer. Okay? So to determine if an infinite series converges or diverges, we must consider the sequence of partial sums or the nth partial sums. So what that means is, if we have an infinite series here, for example, the infinite series of n squared from 1 to infinity, then if we want to know if it converges, we are going to take a look at the sum of the first term. So our first term is 1, right? So the sum must be 1. And then we should take a look at the sum of the first two terms. So our first two terms here is 1 and 4. So we are going to look at its sum. So s sub 2 is equal to 1 plus 4, then it must be 5. And then the sum of the first three terms, 1, 4, and 9, so it should be 14, and so on. Okay? And the question becomes, does this sequence of the partial sums, so the sequence of the partial sums is 1, 5, 14, 30, converge or diverge. So this sequence has been generated from this one, okay? Now, it's probably pretty easy to see from this sequence, this one, it appears that it's gonna increase without bound. So it will be increased to what? To positive infinity without bound. And therefore, the infinite series, this infinite series, diverge. Okay? We'll take a look at the formal definitions in a few minutes. But this time, let's go and take a look first at other infinite series. So here we have the infinite series of 3 over 10 to the nth power from 1 to infinity. So when n equals 1, we would have 3 over 10 to the first power. And when n equals 2, then we would have 3 over 10 to the second power, and so on and so forth. And for us to be able to justify whether this infinite series converge or diverge, then we have to find the sum of these terms. So let's take a look at the partial sums in decimal notation. So the sum of the first term, which is 3 over 10, must be 3 over 10 or 3/10. So in decimal notation, we could see that s sub 1 equals 0.3. Then the sum of the first two terms, so the sum of the first two terms, which is 3 over 10 and 3 over 10 square, and we could see in the decimal notation that s sub 2 is equal to 0.3 plus 0.03 must be 0.33 or 33 hundredths. And then the sum of the first three terms, this one, the sum of these first three terms must be 0.333 or 333 thousandths. And then we could see that the sum of the first four terms is 0.3333 or 3,333 ten thousandths. Okay? So the question becomes, does this sequence created by the partial sums, as we see here, converge or diverge? Now, it looks like these three, we can see the 3 here, is gonna repeat forever. And point 3 should reminds you of the fraction 1/3. And therefore, we see this series does converge. Why? Because as this series approaches to infinity, then there would be a sum of 1/3, right? Because these 3 will repeat forever. So, we could have a finite answer. Then, it leads to a conclusion that this infinite series does converge, right? Again, when we say an infinite series converge if it has an or a finite answer. Again, we should not be too surprised that convergent infinite series does exist. And now let's go and take a look at a more formal definition of converging and diverging series. So for an infinite series, as we see here, the nth partial sum would be given using this notation, where s sub n is equal to a sub 1 plus a sub 2 all the way to a sub n. Now, if the sequence of the partial sums converges to L, we could say that the limit as n approaches infinity of the partial sum or the nth partial sum is equal to L. If this is true, then the series converges. We can also say that the limit of L is the sum of the infinite series. Thus, or otherwise, if S sub n diverges, then the series also diverges. I hope that you have fully understood the previous discussion that we had. So let's proceed to the divergent test for a series. So if the limit of a sub n as n approaches to infinity does not equal to 0, then the series diverges. Remember that a sub n, this one, is the formula that generates the terms in the series. So it tells us that the terms don't approach 0 as n equals 1 to infinity, then it guarantees that the series will diverge. Hopefully it makes sense to you because there's no way to an infinite series can converge if we're adding numbers that don't approach 0. So for example, if we take the infinite sum of 3n over n, and if we take the limit as n approaches infinity of a sub n, so our a sub n here is represented by this one, 3n over n. So if we take the limit of a sub n, which is 3n over n, as n approaches to infinity, then it would equal to 3. No, so the limit of a sub n would equal to 3. And since its limit doesn't equal to 0, yes, because the limit is 3, we can say that the infinite series diverges. Okay? So if the limit does not equal to 0, then the series automatically diverges. It's also true that the limit of a sub n as n approaches to infinity does not exist, then the series diverges. So for example, if we have the infinite sums, if we have the infinite sum n equals 1 to infinity of 3n, then the limit as n approaches to infinity of 3n is equal to infinity. Now, why does the limit of 3n as n approaches infinity is also infinity? Because if you multiply 3 by a large number, then the resulting product would also be a large number. Okay? So, that denotes that it is not finite. Then the limit, or then the series diverges. And then lastly, if the limit of a sub n as n approaches to infinity equals 0, no conclusion can be made. However, if the series does converge, then the limit of a sub n as n approaches to infinity must be equal to 0. So it's a little confusing, but what it says is, if we take a look at this harmonic series, so we'll be writing here the harmonic series to infinity, harmonic series, we take the limit of a sub n. So our a sub n is represented by 1 over n because this is a harmonic series. So if we take the limit of a sub n, which is 1 over n, as n approaches to infinity, we do get 0. But it does not tell us that this series converges. It tells us that it may or may not converge. But it is true that if it converge, the limit of a sub n as n approaches to infinity does equal to 0. Thank you for watching, guys, and I hope you have learned something today.